In this video, we're going to talk about the input current measurement capability of the ZL8800. Now the ZL8800 is a two-phase or a dual output device, but you do get one input current measurement per chip. So what this means is, if you're using a two-channel output, you're just going to get the single measurement. But in a two-phase application, now you can actually use that current measurement to monitor efficiency of the device. The way it works and is implemented is, it's just a shunt resistor that's used. And this is going to be a small couple milliohm resistor. Now the thing you have to be careful of is the maximum voltage you can see across the input for the differential sensing is 20 millivolts. So you need to make sure that you calculate your input current and the resistor appropriately, such that you're always below 20 millivolts if you want to get the reading. Quick way of doing this, just calculate what your output power is and use a worst case efficiency for max load. And then from that, you can size approximately the input resistor. If you don't wish to use this function, you can just tie these two pins, the IN positive and IN negative, to the VN. One practical consideration you may want to take in mind is placing this resistor before you have any of those high frequency ceramic capacitors for bypassing. Because when this high side switch turns on, you're going to get a lot of AC current circulating through those caps. This resistor, what you really want by placing before is, you see the average current coming in. Now we can go to the bench and take a look at the GUI on how this input current measurement is taken and what results we see. So let's do a demonstration showcasing the ZL8800 with the input current measurement. This is the dual phase board for the ZL8800. So it's using both of the channels tied together at a single output to create a two-phase solution. You'll notice on the board we have a resistor that's placed here near the input. This is the current sense resistor that's used to measure the input current. It's a 5 milliohm resistor, and we're just measuring the voltage drop across it with internal ADC. So right now, as you can see with the GUI, we're using a 12 volt input, a 1.2 volt output, and we don't have any load current. Now as we start loading it down, you're seeing the GUI, the load current would change, and also the input current would change. So let's put a 5 amp load on. And right away in the scope, we have a current probe connected to the output of the device, and you can see that the load current starts increasing, and the input current will increase by a small amount also. It's fairly linear, so as we keep increasing the load, we'll accurately be able to track that, and the input current should follow it roughly the same. So let's move up to 10 amps. You can see the output current is about 5 amps per division on the scope, so we're pulling about 10 amps load right now, and the input current is following it commensurately. I can keep increasing it. I can go all the way up to 20 amps. And once again, we get accurate tracking with the GUI, and the input current is accurately tracking also. Now you notice the input current doesn't appear to be quite linear. That's because as we increase the load current, we're actually moving up the efficiency curve. So we're moving from maybe 82% to 85% to 90% as we start moving across the load range. Because this part's really optimized for high efficiency between 20% to about 80% of full load. This evaluation board is capable of doing up to 60 amps. It's designed to do 30 amps per channel. And once again, as they're combined, it means a total output capability of 60 amps. For more information, please continue watching the remaining videos. Or you can evaluate your own ZL8800 by getting an evaluation board from intersil.com